going to open the employee data. And let's talk about inferential analysis. And we said there are two types of analysis, descriptive and inferential. And for inferential, we said these are the analysis you do, not just by describing how your data looks like, but instead you look into relationship, or how does one variable relate to the other. And actually this forms the basis of a research process. And we said for you to be guided on how to conduct your analysis, there are 5 steps that you should have in mind. And one, we said you need to know on how to identify your test statistics, or you should identify the test statistics that you're doing. That's step number 1. Step number 2, we talk about formulating your hypothesis. And hypothesis can come clean as long as you understand the problem. And we said all research starts with an issue. If you recall, with our case, we were able to see that there are more male managers compared to female managers, which is a problem. And out of that, we were able to formulate some assumption. Of course, if you recall, we talked about, is there a relationship between somebody's gender and them maybe getting a certain employment category. So step number 2, we talk about hypothesis, null and alternative. And I'm sure by now you should be comfortable with the same. Step number 3, we talk about confidence level. So you must also know at what confidence level are you doing your study. And for social sciences, we agree that we always do our study at 95% confidence level. So this is crucial because it will also direct you, or if somebody comes and read your work, they will also know, like, okay, they know what is your error margin. And the most important thing about the error margin is now the next step, which is step number 4. And he said, for you to make a decision, you need to compare the value that you're going to obtain for your alpha and also the probability. So we have the p-value and also the alpha value. So step number 4 is just comparing the two values. And the rule of thumb is when the p-value is less than the alpha value, then that is when you reject the null hypothesis. After you have either reject or fail. So again, it's not always at all time you'll be having your p-value being less than alpha, but at least you know how to guide yourself in such an event. And among the test statistics that so we said, after you make a decision, of course, the next thing is conclusion. After conclusion, you should always go and now do what we call recommendation. So we'll also have a chance to see by the time we're doing status software, we should also be comfortable with the maybe how do we come up with the recommendation. But for now, we're focusing more on analysis. We did chi-square. It was basically a test statistics to compare or to check relationship between categorical variables. We also did Pearson correlation. And for correlation, we said this is when one of your variables is continuous and another one is also continuous. We were also able to do independent sample t-test, which is the same principle, but what makes the difference is how your data looks like. So if you're comparing a data that is continuous and another one is categorical, then you'll say you're doing independent sample t-test. Now, we also mentioned yesterday during correlation that correlation analysis does not tell you cause and effect. So what if you want to know how much of a variable affect the other? So if you look at maybe the example of salary and education level, we said based on the correlation coefficient, and significance, but we cannot tell if one regression analysis. So when you talk about regression, I'll be biased with a linear model. And when we talk about a linear model, we borrow from the concept of least squared, or we sometimes call it OLS. You have the notes that, so whatever I'm going to talk about today, you already have this document with you. And it's more like a summary of as far as regression is concerned. For some of you, most of the concept you've already covered in class, but nonetheless, we have a chance to learn regression. And here with us, we will use an example of assuming somebody's salary. Okay, you want to know if education changes by 1 unit, how will the salary respond as a result of that? Okay, so we'll also see other examples of regression. We need to know what is how to come up with a model. And they said for linear regression, we'll be borrowing a lot from a linear function. We'll also go and understand how to now do the estimate. And now actually that is now what we call analytics. So you estimate your Y based on the behavior of your X's. You also need to understand what's the difference between maybe a single and multiple regression. And here is just, it depends on the number of independent variable that you have in your model. So if you only have one predictor, for instance, you only have education as a predictor of salary, then you can say that's a single regression. When you have more than one independent variable, then we call that a multiple linear regression. We'll look at how to interpret the coefficients, which is the most important part. But actually, before you jump into interpretation of the coefficient, you need to do some tests. And the few tests that we need to look at are actually 3 of them. So at the end of this class, you should be comfortable with first understanding what is coefficient of determination, or sometimes we refer to it as R squared. Also, you need to know what is F-test and also T-test. Until you have interpreted all these 3 tests, then that is when you can go and talk about the coefficient. And of course, we'll also need to understand what are the rules, what are the thresholds for R squared, what is T-test and F-test. So let's talk about examples of regression analysis. And for instance, if you want to understand how the number of hours that a student dedicate to studying, how does it affect their grade? Of course, maybe you might say the more somebody goes to the library, which I'm not so sure if it's the case, the more, maybe the higher their grades they're supposed to, as a reflection on the amount of work they're doing. There's one example where you can use regression. So that means you want to look at the number of hours studied and the grade of a student. Of course, we can look at education and income. So in this case, I think that's what you're going to use in class. So for income, we mean maybe salary. You want to know if somebody's education changes, how will salary respond to that? We can talk about prices of houses. The more bedroom a house has, the higher the rent. Of course, this is common almost everywhere. We can also use regression for understanding stock prices based on the market changes. And for those guys who are trading, understand, or I'm sure right now we are facing recession. So how does a recession affect the stock prices? I think regression will come in handy there. Uh, so if you use this data set of ours, we are going to use education, and maybe I can also have previous experience. Let's say, let me use education and previous experience to predict someone's salary. Any question or concern, you can write on the comment section, or you can unmute your mic and talk to me. So we have said we need to do 3 tests, or we must understand the interpretation of 3 tests before we talk about coefficient. Okay, so I'm not so good with following this the PowerPoint. So if you find me that I'm maybe deviating from whatever is being presented, it's one and the same thing. So you'll just read them later. But of course, we agree that the reason why we're doing regression is because correlation does not tell cause and effect. And of course, that's why we're opting for a regression. And you can say the cause and effect relation must be determined using a theoretical model or a logical reason. What does this mean? As much as I think we'll also see this case with the variable experience, whereby you will note that sometimes the results findings of your data might not correlate with the theoretical findings that have already been established. And of course, now you as a researcher, you need to understand the dynamics of your variables, and also with a good knowledge of theoretical backing, you'll be able now to arrive at the correct conclusion. And actually, that's why before you come to this class, you should pay attention to what you're learning in your degrees or whatever courses that you guys are doing, because you will do theory out there, and then you come here, I'll now show you the practical so that you can be able to relate the two. Let's go into now the model. And we said a model that you're going to use is linear. So what does it mean? The linear regression model described how the dependent variable is related to the independent. And we said we're using which variable? The model is y is equals to mx plus c. There's a standard. How do you draw a line? Y is equals to mx plus c. So that is the mathematical arithmetic function that you're going to borrow to now apply economics, or now fit in a model that we can be able to do our prediction. Now, what are the elements of a model? One, you have the y, which is the dependent variable. In this case, between salary and education, we can say that salary depends on your education and not the other way around. So, of course, in determining what is your dependent variable and independent variable, that again is more of now the logical understanding of the researcher. We have the beta naught, which is more like the constant term, so the c in the function. And for constant term, you can understand it as the intercept. And of course, for the guys who are doing economics, maybe you relate more with the autonomous consumption. Of course, with the definition, you can tell maybe that what you consume when your y is 0. We have the x's, so we have x1. And if you recall, we said if you only have one independent variable in the model, then you're dealing with what you call a simple linear regression. If you're having more than one independent variable, then that's when you're talking about multiple linear regression. So x1 is the first independent variable. So in this case, I want you to picture x1 as education. Of course, I want us to do a multiple, so we will not have education alone, but we will say, what if we use education and previous experience to predict somebody's salary? This is the last part, is the error term, or sometimes you call this stochastic error term, or other books they call this disturbance error term. There are a lot of words that are interchangeable there, but the only thing you need to understand here is in fitting this line, it will not cut across all the points, but instead it cuts across as many points as possible. And now the difference between the actual points and the estimated, now that is what makes the difference. And we refer to that as the error term. Now that we understand all the elements or the components of a model, then let's talk about estimating a model. And I've said regression is all about fitting a line. So you have several points and your job is to fit in a line, and that line should cut across as many points as possible. And like I said, we will have now, for instance, the red button you're seeing here is an actual point in your distribution. And then the point where the line cut across, then you say this is the estimated point. So the difference between the actual point and the estimated point is what we call the error margin or the disturbance error term. In other words, it will help you in calculating the R squared. Okay. Now, let's jump into now understanding R squared, now that we are even talking about variations. So when we talk about sum of squared variations and how to come up with total variability in your dependent variable, then R squared is what you need to look for. So let's understand what is this R squared. By definition, you can say R squared entails the overall percentage change or variation in your dependent variable that is attributed to your independent. Let's do that again, and then I will, of course, explain. So we say the total percentage variation in your y that is explained by the x's. That is what is referred as the R squared. And basically, if you want to understand, it's just the r's, the small letter r, which is now the correlation coefficient. When you square it, you now get the R squared. What does that mean? R squared will tell you the percentage change of your dependent variable as it is explained by the independent. If you use an example of our variable, which is salary, we can say the percentage change as a result, a percentage change in somebody's salary as a result of both their experience and their education is what we refer as R squared. Let's put it in terms of figure. Let's go ahead. So assuming I do my study and I obtain, let's say, an R squared of 0.8. Okay. How will you interpret those figures, or how do you put now all these things that I'm talking about into now making sense, especially to someone who has not been to, let's say, a statistics class? So we can say now, first convert that coefficient to be a percentage. So if you're having 0.8, then you'll have 80%. How will you interpret that? Now you'll say 80% of changes in someone's salary can be explained or attributed to 1, their experience, 2, their education level. For the guys who are doing economics, the threshold is 0.25, let's say 25%. If you obtain a coefficient or R squared that is lower than 25%, then you can say your model is weak or it's poor predictor. It's too weak for prediction. And these are some of the things that keeps people in universities, because you cannot graduate before your model passes such a threshold. And now what do you do in such a case? We always say, now in an event that you're having an R square that is less than 25%, then you have no choice but to go and find out other independent variables. So, for instance, if it's salary, now you say, okay, apart from previous experience and education, which other factor affects someone's salary so that it boosts on your R squared? But we will look into all this when we'll be handling our data, especially during stata. Uh, the next one we talk about is AF-test, because we said we're going to do 3 tests before we jump in into interpretation of the beta coefficient. AF-test basically measures the overall predictive power of your model. And what this means is, does your model in general, the combination of both your y and your x's, does it have statistical significance? And the value. Remember yesterday we say what? In an event whereby your p-value is less than alpha value, then that denotes that your findings are significant. Why are we saying that? Because that is the only point whereby you reject the null hypothesis. What is the null hypothesis? The null hypothesis is always the status quo. So in an event that you're rejecting the status quo, then it means your findings must have been significant. So when we will do F-test, we will only focus on the probability value. And then we compare that with the alpha value. And with that results, we will tell if the model is significant or not. The last test, which is t-test, we'll say t-test measures the predictive power of each independent variable. Okay, I think I need to stop using the presentation. So we said t-test measures the predictive power of each independent variable. And I'll explain this before we jump into the practical part of it. Up there, we've just said if you obtain an R squared that is less than 25%, then the solution is you go and find other independent variable. Hope we are still on the same page up to this point. Now, when you're bringing other independent variable into your model, t-test is the one which is going to tell you if a variable is actually a predictor or not. Again, the same principle. So we're going to get p-value for each independent variable, and we will look at their probability value. In an event that we have an independent variable that has a p-value higher than alpha, then we'll say that independent variable does not belong in the model. Okay. Now let's just summarize this before we jump into the practical. So we said R squared will tell you the percentage change in your Y. F-test will tell you the overall predictive power of your model. And lastly, t-test will tell you the predictive power of each independent variable, so that whatever variables you're having in the model, they should be significant. Once you have done all this, then you can say you are ready to interpret now the beta coefficient. And how do you interpret the coefficient? So for beta 1, for instance, you will say, while holding all the other factors constant, a unit change in education salary respond by that beta value. Same case applies to previous experience. So you'll say, while holding all the other factors constant, a unit change in previous experience salary respond by that beta value that you're going to obtain. So let's observe what I do, and then you'll also have a chance to do the same on your end. To do regression, let's go to analyze. For regression, just go to analyze. Then regression, of course, this is the most basic regression that is there. Maybe as you advance your knowledge, you'll also interact with other types of regression. And for now, I'll select linear because we're borrowing from the linear function. My dependent variable is current salary. I'll select current salary, take the dependent. My independent, now I will follow what you call how your model looks like. So if x1 is education, then it means education should be the first independent variable to be entered in the model. I will start with education and then previous experience. Of course, I think you remember when you talk about previous experience being in years, and this is where now it should come in handy so that you don't tell people you have 144 months of experience. He said it's good when you report in months, sorry, in years instead of months. You can do regression in what you call stepwise, and for stepwise, this is where you give the software power to decide to enter each model at a time. But I think let's understand first the basics of regression before we jump into now talking about things like stepwise and so forth. So I'm just going to click OK. And we'll go step by step in interpretation. So we'll start with the model summary. The model summary will provide for us the R squared. So here we can tell that we're getting 0.44. The drill is convert that decimal to a percentage. So we're going to say we're having an R squared of 44%. So what does this mean? We'll say 44% of changes in someone's salary can be explained by their education level and previous experience. The remaining 56% are now other factors which are not in our model. Let's do that again. First, you convert the coefficient from a floating point to a percentage. Percent as the R squared, and the explanation will be current salary can be explained by the previous experience and education level. The remaining percentage, which is around 56%, are now other factors which are not in the model. And some of you will face this challenge maybe when you are defending your project. Professor's best way is you don't have to go and find a new book nowhere that nobody has done before. But you can go and review a certain research topic that was done before, and then go and check what did they achieve in as far as their R squared is concerned. So if they achieved 44%, you can come up with a new study and then go and find out what is this factor that attributes to 56% of someone's salary. And that's novelty. You can defend that in any institution in this world. Let's talk about ANOVA. And ANOVA is also what we refer as F-test. What does F-test do? You say it will tell you if the model has an overall predictive power. Is it fit for prediction or not? So I'm focusing more with the p-value, and I'm seeing the p-value to be 0.000. What does that mean? If I was formulating an hypothesis, then my null would be the model is not fit for prediction, and then alternative will be the model is fit for prediction. Now that I'm getting 0.00, then I will reject it. The model has overall predictive power. That means it is significant at 95% confidence level. Now, I'm ready to go to the next test because now I've already passed both the R squared and the F test. And before I interpret the coefficient, we talk about the t test. So the last table on coefficient, we can see we have the t values and we also have the sig. If you go back to the explanation of a t-test, we say t-test measures the predictive power of each independent. And we're just going to focus more with the p-value. Education, I can see that I have a p-value of 0.000. This means that education is actually a predictor of salary. That means it belongs in the model. Same applies to previous experience, but you can see for previous experience I have 0.038. What does this mean? Previous experience is moving towards the alpha value, which is almost becoming insignificant. So it means if these figures increases, then you can say that previous experience would not have been a significant member of the model. I really hope I'm not confusing there. Okay, dicta. That's what I mean by these figures that you're having here.
Mwalimu, hello mwalimu.
Now,
Teacher.
we have good. Yes, Abdallah. Yes, I can hear you. You have a question?
Yeah, teacher. I have a
Yes,
simple
proceed. I
question.
can hear you.
Uh, teacher, if you look at R square, it indicates that it is 44%, right?
Correct. That's correct.
Yeah. So that 44% is education level and previous experience. So are we
Yep.
dividing that? For example, those are two variables, or how which one is more? How
Uh,
we
so 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 let's define first the R squared, and we said what is the role of R squared? And we said R squared will tell you the percentage change, the overall percentage change in your dependent variable as explained by the independent. So regardless of the number of independent variable you have, it doesn't matter. What we're just trying to say is what percentage of change in your y, which is the dependent variable, is as a result of changes in your dependent. That's why when I'll be explaining now, but if you look here now, we're saying what? If previous experience changes by 1 unit, and while of course holding all the other factors constant, then salary, let's understand that. Let me do that again. So we said what? A unit change in previous experience, while all the other factors are held constant, then it means somebody's salary will increase by this amount. So this is the unstandardized beta. So while holding all the other factors constant, a unit change in previous experience, salary will respond by $12. If you are using the previous experience in years, then you'll say salary will respond by up to $144. If you say for education, while all the other factors are held constant, a unit change in education, so you're moving from one education level to another, then your salary will increase by up to $4,000. Which now again takes me back to the issue of p-value, whereby now I can say previous education is a stronger predictor of someone's salary compared to previous experience. And you can tell by either using the p-value or even the beta coefficient. 12 against $4,000. Of course, $4,000 is a greater predictor of salary compared to 12. So when you combine these 12 and $4,000, all these changes is what we now say it is 44%. Other factors which are not here attributes now the remaining, which is 56. I really hope I've responded to the question, but if not, by reading this linear regression file, you'll be able to grasp the knowledge. Unless there's another question, I would concentrate more now with the assignments, because the more you interact with the assignments, the more these things should make sense. And we have the assignment 2. So you guys should be busy this week so that we finish this thing, we do something else. What is assignment 2? So assignment 2 is here. I believe by now you should be winding up with the assignment 1, which is nothing much, just descriptive analysis and some independent sample t-test. You should do the necessary and send your work to me. Let me touch on this assignment 2 because I want to leave you with also this work. And of course, you will read and understand all these things, but I'll just clarify that this is meant to see if you can comprehend information. Can you hold information in your head before you go and now do analysis? That's why they give you a lot of stories here. I'll go straight to the questions. And these details you're having here are just the, what you call the labels or some description on the variables that you are dealing with. So you have results, gender, age, mother's education level. So all these explanations are here. And your first job in this task 2 is you need to import the Excel file. So this is the Excel file that has the data, but the preview of that data is what you're seeing here. Of course, your data should look like this. I hope we're on the same page. So I want you to attempt question A, which talk about test if there's any difference in results on average between male and female student at 5% level of significance. Of course, you should know the type of test that you're doing now. Okay. So I want you to attempt question A and B. Attempt question A and B, and then in tomorrow's class, I think we will do now all the tasks together in class so that you see how you should have gone about it. Okay. So attempt this work before tomorrow, and we will do them in class together after I've received what you have done. And then I think task 2, leave it behind. So we'll talk about task 2 after our class tomorrow. But for now, make sure you have done my assignment 1. And for assignment 2, you're doing question A and B. Questions up to this point?